In this video, I'm going to model for you the strategies that we use in fourth grade for multiplication. So as a reminder, multiplication is the joining of equal groups. So joining is addition, and in regular addition, I could have a group of 29 and a group of 52, and I could join them together. Well, multiplication is a special kind of addition, and it's special because all of the groups are equal. So here I have 4 equal groups of 328, 3 equal groups of 2,807, and again here, or I could say I have 2,807 equal groups of 3, but again, equal groups. The strategies that we use, these 3 here, most of the time these, because they're a little more reliant on numbers, they're based on place value. So we really, again, are trying to establish a strong place value understanding with fourth graders and not just going through a procedure to get to a product, but really understanding what's going on with these numbers. So these are the strategies that they will see and be analyzing. These are the strategies that they will be learning with and using. So I'm going to go ahead and model all 3 of them for you. So here we have the drawing method, and this is a strategy that I typically use for students when I'm asking them to either check their work with one of these to see, or if they're really struggling with one and it's saying, I want you to try to find the value of this, and they're really struggling with that distributive property, when in doubt, draw it out, is what I tell them. So moving on, I'm going to start with this drawing method. 328 groups of 4. That would be a lot of groups to make. So I'm going to use what I know about the commutative property, and I'm going to do 4 groups of 328. So here's 328, 328, 328, and 328. All right, so I have, 4 groups of 328. And now I'm going to join them. And I'm going to use what I do in addition and see if I can regroup any of my ones. So I got a lot of them. See if I can make a new 10. So I have 8, and right here I could have 2 more. I could make a new 10. Here I have 6, and 4 more. I could make a new 10. Here I have 4, 5, 6, 7, 8, 9, 10. Make a new 10. And I don't want to forget about these 2 right here. They were not regrouped. So I have 2 leftover ones. Let me look at my tens place, see if I can regroup to make a new 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, I can make a new 100. So I'm going to regroup those and make a new 100. And I can't forget about that 10 right there. So I got 1 10 that wasn't regrouped. Let's see if I can regroup any of these 10s to make a new 1,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hundreds make a new 1,000. And I have 3 left over that are not going to make that new 1,000. So there we are. And then my thousands, I have 1 of them. So 4 groups of 328 or 328 groups of 4 has a value of 1,312. All right, so again, this is the strategy I say. If you've tried these, you still can't work it out, use a visual here. Use a drawing. That's going to make sense to you. All right, now on to the distributive property, which really is solely based on numbers and understanding, again, those place value understandings. So the distributive property, the way that I help the fourth graders understand is the distributive property is breaking up a number to do easier multiplication and then joining it back together. So breaking it up for a few minutes so I can do a little bit easier multiplication and then joining them. So what I'm going to do is I'm going to break up this larger number because the 3 is not a complicated number. You want to break up the larger one, and you break it up into its place value. So it's the 2 is 2,000. The 8 is really 800. The 0 has 0 value, and the 7 is 7. Again, here's that place value understanding coming into play here. And what you notice, for those of you that go back to the traditional algorithm, that this is where you distribute that 3 each time. That's what you're doing with the actual numbers. So I've broken it apart, and now I'm going to do a little bit easier multiplication. Well, where does the multiplication come from? This other factor. So it's going to be 2,000 groups of 3, or 3 groups of 2,000. 800 groups of 3, 0 groups of 3, and 7 groups of 3. This is easier multiplication to manage than this right here. So I'm going to start with my ones place, 3 groups of 7. If it's automatic for you, then you know that that is 21. If it's not automatic for you, you can count by 3s, count by 7s, or make a drawing. Here I have 3 groups of 0 or 0 groups of 3. I know when one of the factors is 0, the product is actually, 0. All right, here, some fourth graders are starting to notice a pattern that 3 groups of 8 is very much related to 3 groups of 800. There's these 2 placeholders, and a lot of times then, or all of the time, there's going to be 2 placeholders in the product because 3 times 800 is just, it's like 3 groups of 8, but it's 3 groups of 800s. So it's automatic, or you could draw it out that 3 groups of 800 is 2,400. And you'll notice it's like 3 groups of 8 is 24 with those 2 placeholders. People are starting to see a pattern there. And I want to use that pattern if I notice it. It makes my multiplication a little bit more efficient. Same thing here. I could think about this like 3 groups of 2, and then notice that it's going to have a product with 3 placeholders like that. So 3 groups of 2 is 6. So 3 groups of 2,000 is going to be 6,000. So I've broken it up to do easier multiplication. Now I need to add it back together. So I'm going to do 6,000 plus 2,400 plus 0. I could add it in or not. Plus my 21. And when I add all of that together, I'm going to get 8,421. Okay? So a lot of times in my classroom, we call this the distributive diamond because we're breaking it apart, and then what we did here is we added it back together. So we're seeing kind of this diamond shape. And so it goes with the distributive property, but that's just a way we try to understand the steps. All right, now area model, you're going to see a really big correlation to the distributive property. So in the area model, we want to start by drawing a rectangular area here because the reason that the area model works is because multiplication is like invisible arrays. Again, there are 3 rows here with 2,807 in each one. This has 2,807. This has 2,807, and this has 2,807. But instead of us drawing all of that, we got to start visualizing it a little bit more. We got to start visualizing what's in those place values. So now the way we remember it is that this longer side is where this longer number is because it has so many place value digits here. So I need to break this up into the thousands, the hundreds, the tens, and the ones. And my smaller factor just goes on this shorter side. So again, that's the way that we try to remember it. All right, so now I got to break it up. This here is its 2,000s. Here is the 800. Here is the 0 and the 7. Now you'll notice this is very similar to this step right here. All right, now I'm going to do a multiplication of these smaller arrays. Again, there's an invisible array in here, 3 groups of 2,000. So if you notice, it's 2,000 times 7 or times 3. 3 groups of 2,000. Okay, so 3 groups of 2,000. Well, that's a lot like 3 groups of 2 is 6 with those 3 placeholders. That's 6,000. And you'll notice this equation here is the same as this equation here. All right, so now I have 800 groups of, oh, where's this number come from? 3. So 800 groups of 3. Oh, I notice it here. 3 groups of 8 is just like 3 groups of 800. 3 groups of 8 is 24. 3 groups of 800 is 2,400. Again, there it is. All right, I have 0 groups of 3. Anytime a factor is 0, the product is 0. I could write 0 groups of 3. All right, and then my last one, I have 7 groups of 3. 7 groups of 3 It might be automatic. You could draw it out. You could count by 7s or count by 3s, and that is 21. Again, same equation here. So I have this smaller area, this smaller area, this smaller area, this smaller area. These are called partial products. These are the partial products. Now I need to find the whole area, so I'm going to add them together. So again, 6,000, 2,400, 0, 21. I have my partial products, and I'm going to add them together. And again, same equation, same product. So there's a huge correlation between these two. They're connected. It's the exact same thing, but this is a little more visual, whereas this is more a process that's based on numbers and distributing that 3. All right, so these are the strategies that we use. They can be used for any digits, 2-digit here, 3 digits, 4 digits, and beyond. We'll mostly be focusing on 2 digits, 3 digits, and 4 digits. So use these strategies when you're doing your homework, when you're practicing, any of those.